The Bahamas. A place of legendary beauty. Built over millennia on a foundation of ancient ocean coral. On its 3,000 islands and islets, there is a constant struggle between life and death for the most fearsome and magical creatures on the planet. Beneath this tropical paradise on Abaco Island lies a world forged by millions of years of geological activity. At the heart of all the Bahamian islands is limestone, created from sand and coral in the warm, shallow seas, which inspired the Spanish name Baja Mar, which became Bahamas in English. Now, more than 4 kilometers deep, the soft and porous limestone has proved vulnerable. Over thousands of years, fresh water has eaten away the rock to create the caves and blue holes that dot the islands. Among the diverse ecosystems of the Bahamas, the realm of caves and blue holes is spectacularly beautiful and also mysterious and difficult to explore. The caves and blue holes are home to many species, and a surprising time capsule of the history of the islands. Each dive holds the potential for new discoveries to document not only the recent past, but even clues about the origins of life on Earth. Their secrets are being slowly revealed. Today, dry flank margin caves on Abaco Island reveal clues about the process that created the caves and blue holes. Flank margin caves were formed at times when the limestone was at sea level. Over thousands of years, fresh rainwater absorbed carbon dioxide as it fell, and when it interacted with the soil, to create a weak acid. This acidic solution dissolved the stone slightly. Where the fresh water mixed with salt, it slowly worked to carve the networks of caves, caverns, and channels. As the rainwater continued to percolate through the stone, absorbing more calcium carbonate, it dripped into the caves. When this solution of dissolved limestone met air, the water evaporated and the calcium carbonate turned to calcite and bonded with stone. While the water dripped from the ceiling, stalactites were formed like stone icicles. As water on the ground evaporated, stalagmites grew. With time, the two structures sometimes joined to create stone columns. Forests of speleothems, stalactites and stalagmites, create mystical landscapes in the darkness. One of the most famous underwater systems is called Ralph's Cave. Ralph's is the third longest underwater cave in the Bahamas. To date, nearly 3,000 meters of its labyrinth have been charted by highly trained divers. Ralph's is a relatively new geological feature, formed since the start of the last ice ages, some 350,000 years ago. Calcite crystal formed exclusively from limestone is either white or translucent. Iron can add shades of red, orange, and brown, manganese, blue and black tints. This purple shade was produced by the presence of red Saharan dust in the crystal matrix. During its history, the rise and fall of the ocean have filled the cave with water at least 4 times. But the cave formations were shaped while the caves were dry. This area is called the Tulip Pool for its distinctive crystal features. Unlike many cave features caused by dripping water, these dog-tooth spar crystals grew out of a pool of water supersaturated with dissolved calcite, like a child's experiment to grow crystals on a string. These crystal draperies mark the entry to the chamber. They are so translucent, they act like the stained glass in a church window, through which shape and movement can be perceived. Researchers believe they are relatively new, only 13 to 20,000 years old. The draperies are so delicate. Their survival here in such great numbers is unprecedented. This chamber is called the Glass Factory and contains thousands of intricate crystal straws. As the straws formed, they were hollow. Some have filled in to create stalactites, but remain some of the most fragile formations in the caves. These growths are called helictites. Researchers cannot say exactly how they form. Rather than water dripping to the floor to create a stalactite, water drops evaporate along random axes and appear to defy gravity. Other crystals resemble butterfly wings. Their survival here in a flooded cave is remarkable. Taken together, the collections of pools, straws, and draperies of Ralph's set it above any cave on Earth. Divers must use the utmost caution here. Any movement up or down would result in the sound of breaking glass, and the straws would be destroyed forever. The scattered islands and islets of the Bahamas sit atop two giant banks of limestone formed of ancient marine sediments, like sand and coral. At least 4.5 kilometers thick, the limestone is very porous, and salt water fills its underground voids not far below the surface. Over thousands of years, fresh rainwater absorbed carbon dioxide as it fell and passed through the soil. It became acidic, especially when it encountered the salt water. It then ate away at the stone to slowly create cavities, then caves and tunnels. But the interaction between the fresh water and stone that formed the caves never stopped. Sometimes, the stone became so weakened that the roof of the cave might collapse to reveal a chasm open to the sky. With rising sea levels, they filled with water, and the famous sinkholes of the Bahamas were formed. This happened so frequently that the Bahamian Islands contain the highest concentration of these formations on the planet. This inconspicuous surface is a window to historic discoveries, thousands of years in the making. In addition to housing present-day species, blue holes also provide insight into the ancient past. This 34-meter-deep inland blue hole was formed by a cave-in. A bell-shaped pit opened up and dropped about 10 stories to the bottom. As divers descend through the fresh water of Sawmill Sink, they eventually encounter a halocline layer. Halocline layers occur where fresh and salt water meet. The difference in densities traps leaves and other vegetation. The decay of this organic matter creates hydrogen sulfide. The cloudy, then orange gas blocks light from penetrating deeper. Divers can't linger for long with poor visibility in this corrosive atmosphere. Below the halocline layer, the water is clear but very low in oxygen. Over the years, hurricanes and exposure have destroyed the Bahamian Island fossil record. But scientists say the low oxygen environment in Sawmill Sink has preserved the most crucial fossil finds in the West Indies. A key discovery was of an owl roost once housed in the dry cave, complete with the remains of the raptor's prey, which included lizards, birds, and 4 species of bats. Other creatures are thought to have fallen into the blue hole, and their remains sank to the bottom and were preserved. Reptile, tortoise, bird, and fish remains litter the hole. Thick layers of organics called peat have entombed the fossils and provided even more protection. More than 50 ancient crocodile skeletons have been discovered here. Its nearest living relative is the Cuban crocodile, which is no longer found in the Bahamas. But Sawmill Sink is more than a repository of the recent past. It may hold clues into the origins of life on Earth. Researchers speculate that these very conditions, the presence of sulfur and the lack of oxygen, replicate the conditions on Earth more than 3 billion years ago, when bacteria were the predominant life form. Bacterial samples taken from Sawmill Sink and 4 other blue holes revealed no shared species. In the emerging field of astrobiology, these discoveries hint at the biological diversity among single-cell organisms that eventually resulted in the evolution of complex life forms on Earth and possibly even on other planets. As they did thousands of years ago, the dry caves of the Bahamas continue to shelter many species. Big brown bats gather here by the hundreds. Highly adaptable, these bats are widespread and are found from Canada to the Caribbean islands. The darkness of the cave provides climate control for nocturnal creatures who need protection from the sun and heat of the outside world. This mammal is an agile and quiet flyer. Near soundless movement lets it catch its main source of food, insects. The big brown bat can crush beetles with its powerful jaws and pointy teeth. As one of the larger bat species, they can vary in length from 11 to 13 centimeters. The females are usually larger than the males. This cave is now a maternity roost. All of the bats here are female big brown bats, or their young. The mothers leave their pups behind to hunt at night. They depart the caves just after dusk and locate the pups again on the return by their smell. In comparison, these buffy flower bats only live in tropical areas like the Bahamas. They are much smaller, only 6.5 to 7.5 centimeters in length. While they do eat insects, nectar and fruit are their main sources of food. Buffy flower bats also congregate in maternity roosts, but prefer hot caves that remain a constant 25 to 28 degrees centigrade. Their pups are now several weeks old and have clung to their mothers since birth. Long after the sun sets, the time to forage draws near and the bats become restless. Buffy flower bat mothers carry their young when they leave the caves until they grow too big. Then they must follow and learn to feed on their own. The bats are not the only creatures to occupy the caves. The shelter they offer also attracts others who wish to build a home undisturbed. The hermit crab, which carries its home, has come to the caves for a different reason. Each day it begins the long journey toward the inner cave floors. The resident bat population above has created a unique environment below. When bats consume their food, their specialized digestive system pushes it through their body quickly. The rapidly digested food makes bat guano rich in minerals and protein, which is what lures the hermit crabs here. Food. They will dine on a near limitless supply. In the Bahamas, water-filled caves and cavities are called blue holes. They are found inland and offshore. Inland blue holes like these are sometimes referred to as sinkholes. Sinkholes were formed when the roofs of caves collapsed, creating voids in the landscape at some time in the past. Ocean fluctuations played a critical role, as the most active deterioration of the limestone is at sea level, where it meets fresh water. Later falling water levels probably accelerated the process. The cave systems of the Bahamas suggest that, at times, the ocean was more than 100 meters lower than at present. So while ocean blue holes like this formed on dry land, rising sea levels cut them off and inundated them with salt water. They are now only accessible to divers through subsea entrances. Corals grow on the entryways and provide ideal places for marine life to take shelter. Ocean blue holes demonstrate dramatic responses to the tides, as the water is alternately forced out of and sucked in every 6 hours. The narrow entrances amplify the effects of tides and currents. Swimming against water rushing at thousands of liters per minute challenges these experienced divers. They must time their descents carefully to ensure they do not meet the strong incoming tides as they try to exit at the end of their dive. As the tide rushes in, it carries in rich nutrients to feed the creatures who live here. These include lobsters and tiny crustaceans who live in the blue hole itself and the tunnels which radiate out hundreds of meters. The outgoing tide then flushes all the waste. To preserve the delicate chemical balance of this remarkable ecosystem. Kilometers from the ocean, inland sinkholes are also affected by the tides. Each day, the water level rises and drops between 60 and 90 centimeters in magical blue hole. With the depth of 104 meters, Magical Blue Hole is the deepest on Abaco Island. From within, the entrance opens out to the bright pine forest above. The halocline layer marks the location at which fresh and salt water meet and rests at a depth between 9.5 to 27 meters from the surface. Divers appear to float in space below the haze. Dark passages lead from the blue hole, but are inaccessible due to the risk of collapse created by its active halocline. The surrounding rock is soft and unstable. A resident species are these light brown cavefish with poorly developed eyes. They have adapted to the oxygen-deprived, light-free conditions over thousands of years and seem to tolerate a range of water salinity. Here we find evidence of ancient stalactites that formed when the cave was dry. Massive speleothems are so dense here, it is like a stone forest. There is little rich soil on the Bahamas, but the availability of fresh water around the blue holes means vegetation flourishes here, and the ones on Abaco are surrounded by these Caribbean pine forests. The pools of water create an ideal habitat for insects, reptiles, and amphibians. A common sight around the blue holes is the beautiful Atala butterfly, recognizable for its iridescent spots. It looks dainty, but has a powerful defense mechanism. The larvae ingest a plant toxin called psychocin, which makes them disagreeable to other animals. The butterfly's red abdomen serves to warn would-be predators. They are fitful flyers and remain near to the ground. The butterflies often mate in late afternoon. The female then deposits her fertilized eggs on leaves to hatch in 4 or 5 days. The Atala butterflies are rather short-lived. Their life cycles last only a few days. The northern curly-tailed lizard also loves to bask in sunny, sandy environments around the blue holes. As a cold-blooded creature, it must acquire heat from external sources, like the sun, so it is only active during daylight hours. Male curlytails are territorial and drive off other males who approach. Like many reptiles, this lizard is covered in rows of ridged scales. These ridges are less reflective than smooth scales and may assist with camouflage. This omnivore is not a picky eater. Insects, flowers, fruit, and even small crustaceans make for a tasty meal. He demonstrates skills as a nimble climber. Its distinctive feature is a coiled tail, which may be a show of territoriality, a mating display, or a survival adaptation. Curled above its body, it may trick predators into attacking its tail rather than its head to prevent a fatal injury. Every 2 to 3 years, fire will sweep through the underbrush of the forest on Abaco Island, which is home to the Bahamian pine. This pine is an indigenous species, but only grows on 4 islands of the Bahamas. These rapidly spreading fires will not generally damage the mature pines. Their resin heats up and protects the tree. But by clearing away the competition at ground level, fire also allows young pines to take root. These fires are so critical to the pine ecosystem. Local authorities use a program of controlled burns to remove the underbrush and give seedlings a chance. A long dry spell in 1999, combined with large fuel loads in the aftermath of Hurricane Floyd, resulted in fires that burned hundreds of hectares. Controlled burns can reduce the risk of larger, more disastrous events. Beneath the surface, nowhere else on Earth is home to the range of cave-adapted species as the Bahamas. Lost Reel Blue Hole harbors many of these biological anomalies. They have evolved to thrive in the inhospitable environment created by the hydrogen sulfide gas located below the halocline layer. It is also dark and extremely low in oxygen. Isopods are crustaceans that have no backbone and a generally flattened appearance. Widely occurring in the natural world, these isopods are specifically adapted to this unique environment, as evidenced by its translucent color. The tiny isopods that live here are omnivores and eat whatever plant or animal material they encounter. A more familiar crustacean is the shrimp. This is Tiflatia, a type of cave shrimp which lacks almost any coloring. These cave shrimp have evolved appendages which increase their sensitivity to chemicals and movement. In their dark environment to find food and mates, they can filter out the tiniest microorganism from the water to exploit any nourishment available here. This is a remipede. Remipedes are one of the newest classes of crustacean to be discovered, despite the fact they are believed to be 100 million years old. Almost all remipedes are found in blue hole systems that contain both fresh and salt water. Remipedes use hollow fangs to feed on shrimp and scavenge from this low-nutrient environment. Little is known of the reproductive cycles, but all remipeds are hermaphrodites. Researchers believe fertilization must be external, as their perpetual movement is thought to make sexual reproduction impossible. This is a Cuban tree frog, native to the Bahamas and widespread throughout the Caribbean. It is an unusually large frog, sometimes up to 15 centimeters. This amphibian usually emerges at night to feed and reproduce. Larger females can produce over 15,000 eggs in one season. And rainfall is thought to stimulate the reproduction cycle. Mating happens mostly in the summer, but the Cuban tree frog can breed year-round in this warm, wet climate. They mature from tadpole to frog in a few short weeks. Cuban tree frogs have a unique defensive mechanism. They are covered in a mucus, which causes an irritating response for anything that touches it. Their front feet are not webbed, and the toe pads are larger than most other tree frogs. Both characteristics allow it to easily scale rocks and trees. It is a gifted climber. Cuban tree frogs occupy pockets of fresh water at the surface of inland blue holes, like this almost hidden entrance to Dan's Cave. Dan's Cave on Abaco Island in the Bahamas holds the record for the longest island underwater cave in the world and presents vast underground waterways for ongoing investigation.
So again, in the entrance, we'll drop our O2 bottles right here at 20-something feet or so.
World-renowned divers Brian Keku and Christina Zanato prepare to explore this exclusive crystal cave.
Yeah, I just think this is an amazing shot. We've never gotten it before, so I think this is going to be
Really?
As they descend further into the cavern, side-mount tanks are preferred for navigating these complex passages because the profile of back-mounted tanks are too bulky. Part of their plan is to stage tanks for the return trip so they have enough air to find their way out. The exquisite crystal formations here are extremely delicate. A single misplaced fin could create irreparable damage. In addition to its physical beauty, Dan's Cave contains a large number of cave-adapted species, many only recently discovered. Like nearby Ralph's Cave, Dan's Cave has developed in stages over about 350,000 years. its history is revealed in the swirl of red. Researchers have discovered it to be Saharan dust, transported and incorporated into the caves during dust events over millennia of the Earth's history. Chambers branch off from the cavern room in all directions. This tight space presents a tricky feat for exploring divers. They must navigate the close passages. They call this technique the squeeze. So far, more than 12 kilometers of passageway have been explored in Dan's cave to reveal dazzling dripstone features. Only a handful of people in the world have experienced these wonders firsthand. Researchers believe that one day they will find a connection to Ralph's cave through one of the submerged passageways that divers have yet to discover. Huge mineral columns fill the vast cascade room. They were formed when stalactites from the ceiling stretched to meet stalagmites growing up, likely over thousands of years. Column growth is measured like tree rings, and new layers were added in era after era. Researchers have even collected core samples to study climatic and atmospheric data over millennia. Curtain-like mineral deposits, called draperies, surround divers as they navigate the seemingly endless cave. The most decorated rooms are located at a diving depth of approximately 23 meters. The rooms are very large. The ceilings range in height from 4.5 to 6 meters. They extend 76 meters into the darkness, and at 45 meters wide, dwarf the size of most hotel ballrooms. In comparison, though, these rooms are all subterranean and filled with water. Nature had no assistance in their creation, carving them out over thousands of years, then decorating them with a simple solution of calcium carbonate dissolved in water, evaporated a drop at a time. From the surface, the caves and blue holes of the Bahamas present a tiny window to the world, but the realm beyond opens into countless chambers, caverns, and channels, tracing and recording the geological and natural history of the region. Ongoing exploration holds the promise of even greater discoveries to tell us about life here, not just today, but even millions of years ago.